So this is actually a redux of a presentation series I've been giving over the last, it's awesome, over the last year or so. And I added actually a whole new series of content that while we are going to talk about both the present and past of cloud, we're also going to look a little bit to the future. So that being the case, I thought it would be interesting to talk about some of the things that I see are more interesting than the current set of discussions regarding cloud, which short of arguments on Twitter are starting to really bore me, only because they're very, very repetitive, and I don't think focused on things that really matter. So to that point, this was something I gave at the Cloud Security Alliance. In this country, I'm glad I don't have to explain what a magic 8-ball is, but I've been on 4 continents in the last 4 weeks, and only 3 of them knew what a magic 8-ball was. So, like, trying to act out what a magic 8-ball was to a bunch of Korean people was very interesting. They're like, what? So, you know, you get a bunch of questions all the time, like, is cloud really a major shift in IT? And I think ultimately, depending upon your perspective, it is certainly a very interesting and notable next step. Is it revolutionary? Is it evolutionary? Probably a little bit of both, depending upon your perspective. We're going to explore some of that. You know, will everything move to the cloud? Is generally a set of questions that gets asked. There's a bunch of folks that talk about the ultimate destination of cloud computing as though everything we've done in IT will simply, in the next 2 years or so, end in cloud, like it just punctuates, boom, stop, that's all, we don't go any further. But the fact that, you know, the question is asked, will everything move to cloud? I think most people who have any experience with or are at all subject to things like compliance, issues relating to IP will realize that companies will still be, in some cases, very risk averse in terms of moving certain things to public-based cloud computing. That doesn't, however, mean that we won't end up with hybrid models where, when you talk about the definition of cloud, and we'll talk a little bit about that as the presentation goes on, your definition of cloud matters very much when you talk about will everything move to cloud? Will everything move to public cloud computing, mass market, low-cost utility providers like Amazon? I think my answer is that's mine. Very doubtful. I'll be interested in yours at the end of the presentation. You know, is the next question that gets asked is all we know and do today, especially in security, worthless in cloud? I'd say absolutely not. 99% of the things that we do, right or wrong, are still applicable, especially in the early days of cloud, and in many cases very useful, although we sit and iterate an awful lot on what we should and shouldn't do. And there are a lot of discussions calling for the need for whole new security models, you know, a complete change in how we view security, which if you kind of look at cloud as a next step platform change, certainly there are differences operationally, culturally, and some technically, but does it mean we toss everything away? No, I don't think so. Is the cloud more secure? The reply is hazy. Try again. I think it actually, without context, it's a really stupid question. More secure than what? And this is part of the problem we get into when we start comparing, for example, things that are hosted, services that are provided outside to you versus, let's say, something that you manage internally yourself. We've had a lot of practice where we're told and sold that a lot of managed services are simply more secure because the provider's entire business is so focused on delivering secure services that if it wasn't secure, you would never use them. Well, if that axiom were to actually hold true, 99% of the companies on the planet would probably be out of business right now, because we all have seen issues associated with providers large and small that make the notion that simply because it's your core business, you're going to do a better job than somebody else. And we're going to discuss what that means and why I think it's relevant. But without context, it's kind of a stupid question. It's hard to compare apples to elephants. So can we trust the cloud? This is the $64,000 question. And again, we're going to kind of run through some models as to what that means. But the issue is, do you have options today? And from a security perspective, the answer is yes, definitely. And we're going to talk about what that means. So before I get into the sections about talking about where the present and past of computing has led us to cloud, let's talk about the future. So the future, I think, of cloud is actually these things. It's also these things, netbooks. It's also these things, thinner and thinner clients. That could be on thicker and thicker platforms, but thinner and thinner clients. And then, of course, these things. And what's interesting about the notion of mobility and is that there are, by rough count, according to the font of all knowledge Wikipedia, there are roughly 7 billion mobile platforms on the planet. Not all of them smart, not all of them used by smart people either, but 7 billion mobile platforms, but only 4 billion people, which is kind of a weird ratio when you think about it. Or did I get that backwards? I think I got that backwards. Yeah. No, 4 billion mobile platforms, 7 billion people, which is still staggering, right? That means almost every person on the planet, there's enough phones for every person on the planet, and probably will be more as these platforms, as they develop, like netbooks, like my kids over there playing with the iPod, not listening to me, or iPad, will attest to. So what's interesting about cloud, and we're going to talk about this as the main body of the talk, is that cloud computing is actually taking the notion of many, many distributed data centers that you could spread, providers would spread resources out, and they're consolidating them back down into mega data centers. So this is one of the biggest ones on the planet. This is Microsoft's new Chicago data center. Enormous, right? Hundreds of thousands of nodes serving perpetually or potentially millions of customers. So while mega data centers kind of re-centralize the apps and data into these mega data centers, these mobile platforms actually redistribute the same apps and data into your little mobile data centers, which would be your pocket. And so what's interesting about that to me is that when we talk about cloud computing and what it means, it's very vendor focused today for the most part. It's like how vendors are adapting their models to serve you. But the demand is really interesting because the consumption modality to me is going to be much more important than what will ultimately be a commodity set of services on the backside. All the providers will look to kind of offer you the same sets of services with some disruption every now and then to differentiate. But what's interesting is the fact that how you consume and end up using that data is important. So how will you choose to protect, and where and with what, and how you invest in how you're going to protect this data ultimately if we have these two different models. So the 8 things, interestingly enough, I'm going very quickly because I'm going to talk about them in more depth, that really start to matter again with cloud computing are open standards and APIs. This is a recurring theme every time we have disruptive innovation. The timing of when standards arise becomes an arguing point about the fact that standards standards seek to constrain innovation. Usually when they're proprietary, yes. When they're open, not necessarily. But since everything these days with cloud services that we'll get into is really exposed or starting to be exposed via APIs, the notion that those are open are very important. Portability, ultimately open standards and APIs yield interoperability, but portability between cloud providers is very important to folks. The evolution of namespaces and registries, how we advertise service availability and then ultimately choose to be able to consume them, because ultimately as these services get very distributed, we have to understand what's available. We've been struggling with this for years, right? We see things like UDDI in web services being able to tell, oh, here's all my services, you can pick and choose to consume them. We need something very similar to that. Transparency through both introspection and retrospection for things like forensics is very, very important. Identity and authentication, strangely enough, the last 40 years have shown us that, and Vint Cerf in discussions when he was asked what he would do differently in rebuilding IP, if he knew what he knew then, what he knows now, would be I'd put more authentication back in, or I'd add authentication back in. A huge problem in public cloud environments when you're trying to federate access to multiple applications and content. Mobility and transitivity, the network really has to change, and change how and why and the manner in which it does what it does. As we'll get into as the presentation proceeds, this notion of abstraction really puts stresses upon how we manage and secure our information application. And the network, which is supposed to, by one definition, be dumb and kind of just a conduit, really stops providing functionality in ways that make it easy to consume and deliver these applications if it's not aware of the traffic flowing over it, and vice versa, or at least the workloads themselves. So the network itself becomes strangely more or less important depending on your perspective. To a provider, it certainly does. If ever there was an issue that highlights the need for SDLC and does not make application or web application security go away, this would be it, since most of these clouds are exposed now almost exclusively via the internet and in public clouds. So it really is a push back to information centricity and survivability, meaning focusing on the data and making these systems survivable so that you can put them in a hostile environment and they continue to function, even under duress, something we've been working on for years and years and years. So what does that mean? That means ultimately abstraction has really become a distraction. We've been so focused on the fact that, ooh, you don't have to manage this stuff anymore, that we're wondering what it is and how it is that this pure freaking magic just happens and cloud just makes stuff work, when in fact in many cases it doesn't. So what that does is cloud becomes a fantastic forcing function. Makes you say to yourself, okay, if my CEO is going to make me outsource everything to provider A, B, and C, and I no longer have direct functional operational control over my content and applications, I better make sure that those applications themselves, as my so-called perimeters collapse around the information and the VMs and the data itself, that I am focusing on the right things. So a lot of this, the kind of more infrastructure moving parts pieces become potentially less important and lets you kind of whether you want to lean on compliance, whether you want to lean on doing things the right way, or risk assessment, you can start really focusing on things that matter. So staying grounded, kind of literally thinking globally, because you don't necessarily know where in some of these large cloud providers your information and content lives. The notion that really what this has done, cloud computing, has taken this notion of deperimeterization or reperimeterization and put it on steroids. Deperimeterization, as pushed by the Jericho Forum, wasn't really about the fact that you don't have firewalls. It's just the protection mechanisms and how you enforce policy and where start to really morph, as we'll kind of discover. The story we actually get from cloud providers is you should plan for fail. Everything fails. It does all the time. We just will engineer resiliency into our platforms. The interesting thing is that in many cases, in planning for fail, for infrastructure to fail, the applications that get deployed and delivered on these newfound infrastructure actually aren't re-engineered enough to take advantage of the resiliency. It's not so. In this case of abstraction, we just think that the network or the provider will take care of it when something bad happens, and in many cases that's not the case, and people get very, very surprised by this. But you should definitely plan for fail. This notion of public, private, hybrid clouds, all these fancy labels. At the end of the day, it all comes down to trust and trust models. We're going to end up with very hybrid models, as we'll see later on in the presentation. So, understanding where your data is, what's more important, all the things we hear about in terms of risk assessment and understanding how your data is consumed. It's like a polka group upstairs. So cloud is really an iteration. It's got a beat. I can dance to it. It's an iteration of a platform and an operational model, right? So James Urquhart said, cloud is not a technology, it's an operational model. And if you think about that, it's really true, right? It's how you adapt what you do, where you do it, and how you do it. I know that's Mike Dunn kicking the wall. It is you, isn't it, Mike? So really, the end product here is just focus on the data, right? It's what we're frothing over in the first place. So if we focus on that sort of thing, we keep that in mind. This is really kind of the next question that comes. So, what will cloud bring me? What does this mean to me? My answer is, does it really matter? We see platform shifts and changes all the time, and we kind of wait for the next big thing in order to catch up. Right? I think all of us realize we're never going to catch up, let alone leap ahead. We have the capability, however, to at least think differently and focus on the things that matter. So what are you doing to secure what you have today? Because that's really, really going to govern what this means when you move to this new environment, much like in the way we've had to contemplate what virtualization has done to our internal operations. So can we trust the cloud? Well, I think, ask again later, especially after the end of the presentation, right? The reality is, can you afford not to? And I found the presentation yesterday from Alex Stamos very interesting, because the title of the talk was something like moving your business to the cloud securely. I think that's accurate. What I actually got out of the talk was, actually, you can't trust the cloud. The cloud is a horrifically untrusted, hostile platform. And by the way, all the stuff you used to do in security, you have to do now more, and even more so in order to deal with some of these changes. And that's kind of an interesting message, because when we get down to it here, as we'll see, hopefully, a lot of the things that we talk about in terms of cloud computing and making it secure is really less about making cloud secure, but making your app secure, which is a very difficult thing, as we all know. So that was the kind of a little bit of a glimpse into the future. Now let's look at the present/past. Anybody know what that is? Anyone guess? Vampire tablet. Nope. Anybody else? It is actually, strangely enough, photographic clamp. Nope. It is actually the accelerator pedal on a Toyota. Now, what is interesting about this is, as a platform, I am told I should trust my minivan. Right? And for the most part, it has a good track record. You know, sometimes bad things happen, airbags go off, sometimes we have collateral damage. But the whole point is this little interesting thing right here. Rare occurrences of excessive friction on contact points. Now, it's rare. It doesn't happen a lot. But when it does, really, really bad things tend to occur. And I think that's interesting because it's rare, yes, but in some cases, potentially tragic. And that's the sticky point with cloud today, is that failures are rare, but the impact radius can be enormous, right? Especially if instead of a minivan, this was a bus that held a couple of hundred people, as opposed to 4. So if you think of cloud that way in a kind of automotive analog, you know, there's a big difference. Well, there is a difference between 4 people in a Prius getting in an accident and a couple of hundred in a bus, or worse yet, in an aircraft, et cetera, right? So when I start thinking about platforms, yeah, rare, but I also want to think about what the impact to risk is. So if we set some context, again, cloud is really a natural, iterative platform progression. It's a great response to a converging set of socioeconomic, political, cultural, and technological advances and stimuli. And it's, you know, and in some cases, it's being able to being empowered by a lot of new technology, things we've been trying to do for 20 years. So if you've heard of adaptive enterprise, real-time infrastructure, things about modernization and automation, these are all good things that are coming out of cloud, both in a public utility model as well as private cloud, which we'll talk about in a second. So cloud, if it is an operational model and not a particular technology, points to the fact that there are actually many different kinds of cloud. So not all clouds are created equal. This talk focuses on public cloud computing. We'll talk about why in a couple of minutes. So at the end of the day, the internet, as it relates to the hosting platform for public cloud, assumes some sort of fictional trusted core. But as we heard yesterday in Alex's talk, and I think I'll be able to substantiate it here, it's in fact an untrusted, unreliable, and hostile platform. All the things we do is basically to provide access into this very hostile environment. And cloud kind of exacerbates some of that. So if that's the case with the internet, then that should be the case with public cloud. I'm going to talk about that. Really, this comes down to trust, right? It's about how we are going to do things differently, who we're going to trust, and why, and ultimately how. So, what is cloud computing? My old friend Fonzie. You know, two interesting perspectives. There is a very provider or technician clinical view, empirical. I made a picture of NIST's representation with delivery models, deployment models, external essential characteristics. You know, very well abstracted, looks very OSI model-like, stacks. It's got plenty of technical terms. These things, you know, abstracting the infrastructure, democratizing resources, making apps available to everybody, self-provisioning, dynamism, elasticity, scale, all good things. But it invites a whole lot of interesting arguments about what is or isn't cloud. But when you ask business people or IT folks what cloud is, they'll usually tell you Amazon Web Services as infrastructure as a service. They'll talk Google App Engine for platform as a service and Salesforce.com for software as a service. 3 archetypal examples of cloud computing. Now that's interesting, but there's another view of cloud computing, which is basically anything that interacts with or interoperates with my data over the internet on any device and any platform is also cloud. So if you talk to your family members, you talk to folks that aren't in IT, and when you take off your IT geek hat and you use some of the tools and toys that you have today, all of these things, by definition, in some cases, are also cloud. So you sit there and you scratch your head, and a lot of these, the disparate consumerization of IT elements and the technical stuff don't line up very well. So everything is cloud today, right? Which is very difficult then to figure out how applications and services that yesterday were called one thing are now today called cloud. I don't want to debate the validity of either. I think that ultimately both have very interesting things to contribute to this discussion. But what is interesting to me is this kind of cloud journey, as it's called, and its impact on security and vice versa. So I'm going to give you the simple view of how the IT industry essentially paints the journey to cloud computing, with over time an increase in federation, workload portability, and interoperability, which will lead to good stuff. So we started with standalone data centers. Ultimately, standalone data centers started to consolidate, especially with virtualization. We ended up with virtualized data centers. Virtualized data centers then ultimately in parallel with the evolution of cloud computing delivered kind of two very familiar sets of capabilities as described by the industry today: private clouds and public clouds. Those operated on your behalf and governed by policy of a single company that could be located internally or externally, and public cloud generally externally run as a public commodity for the most part. So here we had virtualized data centers and standalone data centers talking to public cloud, and virtualized data centers talking to private cloud. Well, what happened in the last year or so is that the public cloud providers realized that if they wanted to capture large enterprise business, they had to start adding features and functions that look like large enterprise. And in many cases, as I talked about before, and I'll talk about more, the thought that you would just pick up applications and move them to the cloud without re-architecting and rewriting them is kind of nonsense. So what they discovered was we need a way of allowing public clouds and private clouds and virtual data centers and standalone data centers to interoperate. So they introduced this notion of virtual private clouds, in which case now simply we have standalone data centers talking to virtualized data centers, which in turn talk about virtual private clouds, public clouds, and private clouds, with private clouds talking to virtualized data centers, ultimately public clouds, and then kind of an overlay of VPN capabilities. Still kind of simple. You kind of understand where things are going. But then what we realized was, in the absence of standards or APIs or certain capabilities and federation, we are lacking some functions. So then we stood up this notion of cloud brokers. So cloud brokers ultimately see standalone data centers talking to virtualized data centers, talking to private cloud, talking to public cloud, talking about virtual private cloud, which in turn talk to cloud brokers, which talk to public cloud and private cloud, offering you services which are ultimately supposed to deliver and fill in the gaps that don't exist today because of the lack of standard federation, workload portability, etc. Well, then they said, as APIs start to emerge, and we get a little bit better interoperability, and we start to see commoditization, things start to stabilize, then what we see is this move to hybrid clouds, which is really a mixture of virtual private clouds, public clouds, standalone data centers, virtualized data centers, all talking to one another, ultimately then interacting with the cloud brokers to fill in some of the gaps. Still pretty simple, right? I mean, you may understand how this works. Well, ultimately then, way down the line here, we're going to kind of sprinkle on the magic pixie dust and end up at this thing called the intercloud, which if you connect all the dots and all the arrows and slow down what I said, what the intercloud really means is the model of cloud will just arrive at the same model as the internet. We have open standards and APIs. Some things you keep private, some things you keep public. We have capabilities that allow us to enforce some access control, maybe better identity, better sets of services, everything living in harmonious glee. But the reality is when you look at all the arrows here, it's very difficult, without even overlaying the notion of mobility and the consumptive model I talked about in the beginning, how any of this will be easy to secure, since each one represents a separate model, even though they may be overlays or hybrids of one another. So this is kind of the problem. So let's break this down a little bit. So when you hear about cloud, you're going to hear about these three models: software, platform, and infrastructure as a service. They are targeted at three different groups. Software as a service is end users. Platform as a service is targeted to developers, let them build apps. Infrastructure as a service is targeted to sysadmins. So from a security perspective, it's interesting to see what this means and what this looks like. So I built a little set of models I've talked about before, but what's interesting here is all of the infrastructure, the compute network and storage facilities, the core connectivity and delivery, and layers of abstraction with a set of APIs in infrastructure as a service is the responsibility of the provider to not only operate, but to secure. Everything above that, here, the VMs and containers, OS and applications and data, is the responsibility of the consumer. So in infrastructure as a service, while the moving parts are hidden from you, you are still responsible for securing the operating systems and the apps and your content, just like you always have been, just kind of outsourcing the moving parts. So providers here maximize availability of their platform and pretty much nothing else. You are responsible for doing the rest and taking advantage of the platform to potentially leverage some better capabilities. So the general focus here is then, from a security perspective, less about the network, since that's abstracted, and more about the host. To give you an example of what this looks like, here's the terms of service from Amazon. You bear sole responsibility for the adequate security, protection, and backup of your content and applications. That should give you a warm and fuzzy, right? I thought I was outsourcing this stuff and I'm going to get better security. Well, it depends. There's a balance, right? There's a certain amount that you still have to deal with. When you look at platform as a service, which is really, if you in a classical stacked model, the same as infrastructure as a service, with a set of developmental and application frameworks that you can write apps to, the line just moves up a little bit more. Now, the good thing about platform as a service is you actually have the opportunity to get rid of entire classes of programmatic issues, because, for example, I could do type enforcement, class enforcement. I could get rid of stupid things like potentially buffer overflows by enforcing that at the programmatic API layer when I write code. But still, you are still responsible for the security of your apps and your data, right? So strangely enough, securing applications is still pretty important. And when you look at platform as a service, here is Google App Engines. You are responsible for the security of your passwords. This is the security section of Google App Engine. More warm and fuzzy. So if you look at software as a service, and I'm not talking about plain old web apps, POWA apps, which were yesterday kind of could be monolithically stacked, could be no virtualization whatsoever, that now have the word cloud in front of them. I'm talking about new generations built on infrastructure and platform that allow you to leverage cloud capabilities. But in this particular case, really from an operational perspective, the provider owns the security models, and you may configure policies to support what they offer you, but they're really responsible for that offering. Soup to nuts. And this actually kind of, Salesforce does a good job of spelling this out. We shall maintain appropriate administrative, physical, technical safeguards for the protection, security, confidentiality, integrity of your data. So that's a little bit more warm and fuzzy to me. And ultimately, they get to do that because there is a trade-off between functionality, extensibility, and security that with SaaS, since they govern the whole space, they can enforce things and stop you from making stupid human tricks, perhaps more so than platform or infrastructure as a service. So that's kind of the base tenets. But what this means to security here is that when you compare these three models and where the line is drawn, really the lower down the stack you go, the more responsible you are. So in software as a service, you RFP or contracted in. A lot of the stuff is contractual. Like, hey, we promised to do this. Great. If you don't, then what? You lose all my data, then what? And same thing with service levels. When you go down the stack here, you really still have to build the majority of it in, right? If you spin up an AMI on Amazon when you haven't armored the operating system and your applications suck, whether you did that internally or not, you'll be one of my taglines is you'll be pleasantly surprised by the lack of change when you move to cloud. Right? The reality is if you suck internally, you'll suck externally even more, with more availability. So ultimately, you got to build it in here, right? And that's important because by merging those technical and consumerized versions of cloud, like people are like, they talk about cloud singular with a capital T, like the cloud, like there's one thing called cloud, and there's clearly not. So when we start thinking about these models and doing risk assessment, understand what this means, we really have to understand that depending on these delivery models, the availability for compensating controls, in some cases get abstracted to be good enough. They may not even be available to you. It means that the provider, in abstracting compute, network, and storage, in this simplifying process, essentially can limit entire classes of visibility and transparency. And ultimately, even with the potential for APIs and open interfaces, when it comes down to cloud, you really end up still being at the mercy of what the cloud provider tells you they do. So it all comes down to trust, which is not unlike everything today. With virtualization, you trust in the hypervisor, and you trust that the vendor ultimately has done a good job. But there's this really notion. To me, there's a notion of corrosive trust, right? It's security by obscurity at levels I don't think we've seen in quite a while. What I mean by that is if you look at, for example, the virtualization underpinnings, most of the cloud providers today from an operational perspective is based on faith or SAS 70. I'm not sure there's a difference. So we have, we've been asked that essentially trust providers, trust protocols, trust hardware, trust software, trust operations and people. No difference in cloud than outsourcing to a provider, but now we're talking about massive scale and this notion ultimately of multi-tenancy. So when people think about this, they think about really the issue of control. Trust does not equal control. We talked about trust. Ultimately, cloud is all about gracefully losing control. I'm basically saying, here, have my stuff. Please do good things with it. Control is often an emotional issue to security people. We can't necessarily justify why we think it's a bad idea because we don't have visibility in some cases, or we don't have the ability to say there's an exploit. That's why not, right? We in some cases have to rely on strange voodoo dances and chicken dolls. But the point is, we say I'm not giving up control of my content and data. And one of the interesting things that goes back to that 8-ball presentation is people are really worried about, security people specifically, about putting their content and data in other people's hands. I maintain that if you hold up what's in your pocket now, most of that application and content is already quite literally in other people's hands. And the issue here is that when we talk about control, we're kind of unprepared for what that does to us operationally. So in many cases, we can get over some of this by saying, look, if I only had some of this transparency and visibility back, so I understand what you're doing with my apps and content, then I'm able to actually focus on the things that matter most. You can deal with the operations. I just want to be able to understand what's happening. The trouble with that is that we have this notion of what I call stacked turtles, right? Turtles all the way down. If you've ever seen turtles, and these are frogs because I didn't have a cute turtle picture, but if you've ever seen turtles sleep, they climb on top of one another. It's like a game of Jenga, right? One falls, the guy on the bottom wants to go take a whiz, they all fall off. And that's kind of the problem that we have today with cloud, because we're stacking clouds on clouds on clouds. Many of these mashup type of Web 2.0 overlays on top of cloud infrastructure or platforms mean that we end up having staggering interdependencies, some of which we fantasize at the application layer, but I'm going to kind of point to some more common sense stuff that I think most of us know. So we're actually building on quite an interestingly shaky foundation. We haven't cleaned up a lot of stuff that we should have. What do I mean by that? Well, we've got things like hypervisor vulnerabilities, lack of trusted computing-based implementations, a lack of standards when it comes to cloud, the reintroduction, not just introduction, but reintroduction of monocultures with consistent levels of new sets of code that run across entire suites of infrastructure, information leakage, substantial downtime in relative terms of the availability of some of these services, and a lot of security by obscurity. All of this stuff is really the same as it's always been, and in fact, in many cases, all of these challenges that exist here in the enterprise and all of these problem sets that we have to think about still exist. Right? Didn't go away. In fact, intensify in many cases. So, this is interesting because this picture was actually part of a video that was taken by a guy sitting in a seat looking outside of his window, and it reminds me of this ancient Hindi proverb that says, just because you can does not mean you should. Use duct tape to secure the wing of an Airbus 320. So this poor guy's getting ready to take off, and he's looking at the guy repairing the plane with tape. That, in many cases, is a great analogy for me for cloud, right? It's got great new technology, get to fly high, just hope to God the wing doesn't fall off. It kind of reminds me of this notion of driving down the street, right? We have these subtle little agreements written in yellow dotted lines that say, please don't kill me. And the only reason they don't is the person coming the other direction generally wants to get to where they want to go as badly as you do. It doesn't prevent people from speeding or crossing the yellow line, and when they do, bad things happen, and then we overreact sometimes. We say we'll put Jersey barriers everywhere, or better yet, we'll automate things by putting these fancy robotic cars that drive themselves. Interesting solutions to what could be much better sets of problem. Interesting solutions that could be answered by much simpler sets of approaches to these problems by fixing the things that matter most. And what's interesting about this, when we think about the evolution of computing and security as a whole, I like to explain it kind of this way, where ultimately, this is how we have consumed our data. This is how it's served up. This is centralization or decentralization of data, and this is ubiquity and speed. So we started with mainframes, with dumb terminals, mostly centralized, kind of unreliable and slow. We went to minis, but I skipped that, and we went to client server, where we had more powerful end node computing capability with more distributed compute on the back end, but still mostly centralized on big file servers, file stores, and getting faster and better. We had the web show up with kind of arguably more intelligent end nodes, but through a dumb experience, or dumber, depending upon which browser you used. This web interface, a simple interface. More distributed data stores, mostly reliable, faster. Web 2.0 kind of took that with virtualization and the exponential growth of the internet, and made these things both kind of in my hand, in my pocket, richer on the client side. New protocols showed up, things like Ajax. We got mashups, and then we had this kind of interesting thing happen with cloud. We have massive re-centralization starting to occur, and as I alluded to, massive decentralization occurring at the same time. Two models at the exact same point in time that we don't do a very good job securing or applying security capabilities to either way. Because ultimately, as you've seen before, and you might have seen this slide, our response to the security industry to each of these has been this thing. Or, as Gunnar Peterson said, as programmatically as we've advanced over time, we have, in one variation or another, seen a tremendously consistent, albeit lacking, response to this, as each thing is kind of an iteration of a firewall or SSL. That's kind of been our response to every single massive programmatic change or cycle change. And the same thing's starting to occur with cloud, although it doesn't have to be that way. But ultimately, I wager that it will be, and that has been proven so far by the security hamster sine wave of pain, and I ripped off Andy Jackwith's hamster wheel of pain. But essentially, this is how we invest in security. This is time. This is a nice, smooth version of what I call the kind of technology overlay function of the theory of punctuated equilibrium, which says you get these big bursts and then it settles down. You get big bursts, which are disruptive innovation. But ultimately, you can start anywhere here. But if you add a cosine here, which then, for example, overlays disruptive innovation, what you find is you're basically 180 degrees out of phase. So every time that we're investing here, for example, at the network layer for controls and capability, now that it's abstracted in virtualization and cloud, they actually demand that you deploy controls down here. So if you're a vendor looking 4 years out with roadmaps that are very difficult ultimately to plan against for disruptive innovation, if you're not paying attention, what that means is that we're always out of phase. And if you overlay attacker innovation, the ability to fill that gap, compress the frequency, and get the amplitude down is very, very difficult. We play this game, so we go over and over. We start with hosts, and we put 27 agents on a host, and we get down to 1 mega host. We say that's a pain in the ass. It doesn't work. Then we say we'll fix the application, so we invest in SDLC, or the programmatic interfaces change, and all the apps break. So we say we'll focus on the information. We can't find it. We can't enforce it. Once it leaves us, we have no way of enforcing policy. Then we say, oh, we'll focus on the users, we'll stop the monkeys from pushing the wrong buttons. That doesn't work so well by itself. So then we invest in the network, and we say speeds and feeds will pick up, but then we encrypt everything so we can't see anymore. So it goes on and on and on, right? And this is problematic, because when you look at what that means from how that's played out over time, it doesn't really bode well. And when you look at, for example, some more of the things that are happening, there's a downside to all this convergence, in as much as as we converge compute network and storage and the speeds and feeds intensify, these issues don't subside. They get worse. And when you integrate virtual security capabilities at network scale, and we're seeing this already, and Alex talked about it yesterday, you have switches today that can do hundreds of terabits per second on the backplane. Most firewalls are lucky if they can do a couple of gigs, or if you are going to buy lots of them or even distribute them in software and hardware, it becomes very difficult in some cases, albeit you have the capability to potentially get to the point that you have a single policy, but it gets very difficult to be able to do this. It's a squeezing the balloon problem with classic issue of kind of Moore's curve, Metcalfe's law, all superimposed on top of one another. Some would argue there's nothing wrong with the internet. I argue with Vince Cerf all the time about there's nothing wrong with the internet. Well, actually, I say there's lots wrong. But before I get into the last part of the presentation, which I'm probably going to run out of time for, there's lots of awesome stuff you can do with cloud computing, especially if you utilize this as a forcing function. Recentralization of data, better segmentation of apps and data when you re-architect them. In many cases, given the capabilities of unification of platform, better logging and accountability, standardized images, better resilience to attack, depending on the type of attack we're talking about, better visibility to process in some cases, faster development, all good stuff. The problem is that I think we're focusing, or the vendors are focusing on this area without a lot of substantive guidance or even solutions. We're technology rich but kind of solutions poor. And the trouble is we're kind of forgetting about the last 40 years. So I like to break things down into 3 blocks when I talk about cloud, or anything really. We've got infrastructure, metastructure, and infostructure. So infrastructure is kind of compute, network, and storage. Infostructure are the apps, data, metadata, and services that ride on top of them. And metastructure is the stuff in the middle that makes it all work. In a non-virtualized, non-cloud environment, the job of metastructure is to bind infostructure to infrastructure, meaning bind the apps to the infrastructure, which kind of makes sense. In cloud and virtualization, that is supposed to be a lubricating layer, right? It is supposed to decouple them, which, if you look at what virtualization does, that's the entire premise. The problem is all of this stuff breaks horribly when you introduce mobility of any sort. And that's a lot of the problem and pain we have today. We're going to cover some of that. Because what this really means is when we think about why I titled the talk the way I did, we're really talking about building clouds on clouds on clouds. And you'll see in a couple of minutes with some illustration that a lot of these cloud services that you think are built on infrastructure that a single vendor operates themselves are actually, just like the internet today, incredibly intertwined with others. We have this notion of amorphous perimeters, the fact that perimeter now is collapsed down to the VM, or in some cases the information layer, and it's coupled with the fact that you're actually living with other tenants on these same systems that maybe your nearest competitor or potentially an attacker. Whereas in our own enterprise, at least the attackers, we have their social security number because we pay them. So this notion of security, socialist security, good enough, the Canadian health law, Canadian healthcare version of security is like, oh, sorry, Andrew. This kind of notion of commingled data in multi-tenant elastic environments where good enough is good enough is an interesting set of pain points for people to grapple with. And these really old crusty protocols and an even more stale approach to integration between what we have today means that security becomes a question of scale. And this scale is a real big problem. It's a great boon and benefit for agility and flexibility, but it sucks when it comes to security. So I'm going to give you you can read the slide later. It basically says, look, these are just illustrations. Don't get hung up. I'm not here to pick on one vendor or another. These are kind of, think of the big picture, not the little illustrations. So if you think, when we talk about those three layers, infrastructure, metastructure, and infrastructure, let's look at the fact that, for some reason we have expectations that physical failures just don't occur in the cloud. We get all shocked. The funny thing is, Rackspace, Amazon, Google, Microsoft, huge power failures have all caused numerous data center outages. Shouldn't be that way, right? That's what we're told, but in case they do. CI Host in Chicago was a victim of robbery. Guys busted through the door with an axe, busted through a concrete wall with a sledgehammer 4 times. Stole switches in their servers like 4 different times. Core IP networks, although this isn't really a physical issue, it's actually kind of like a Fourth Amendment issue. Was interesting in as much as guys show up to search, FBI shows up to serve a search warrant, says, "Great, we want this content and this information. We don't know where it is. It's all virtualized." So they took the entire data center. Right? What does that mean to a Google or an Amazon when these sorts of things start to flex their model? So the physicality of where things are located gets to be kind of important. When we think of infrastructure also, I talked about re-centralization of data. These mega data centers really change traffic patterns. They change the entire consumption model and interchange and peering models. And you add mobility and starting to move workloads around based on the provider's requirements or yours gets really, really interesting. And if you have a failure in a large mega data center with 50,000 cores, for example, that support 100,000 customers, unless I'm doing real-time replication of content and data that coexist with service levels that match 5 nines uptime, you're going to tell me I'm going to migrate an entire data center in real time from one continent to another without outage? That's very kind of interesting. And what that means over shared fiber, because this is a map of the kind of the inner tubes, quite literally, suboceanic cables, and we've seen already what happens when you have an earthquake in China, like most of the Middle East goes bye-bye, or when you have accidental, quote unquote, 7 anchors being dragged across the bottom of the ocean that happen to cut 7 different fiber points. Sure, it's an accident. You see most of the Middle East go bye-bye. So the kind of interesting thing here is when you think about the shared fiber and things go boom, besides the fact that the beauty of cloud, as I say, is that the notion of infinite scale comes with the potential of infinite fail, right? So while some companies own their own dark fiber, the majority of the kind of, I don't want to say second tier to make it seem more diminutive, but cloud providers that aren't at the scale of Google or Amazon depend upon shared fiber just like most of the rest of the internet does. So even if they're medium size, migrating 20,000 nodes or data centers or shifting workloads across shared fiber means that, ultimately as these things start to pile up, the notion of what this means if your bandwidth goes away or gets plugged is very interesting. We've seen kind of going up a layer, the abuse by the insiders or attackers. Actually, it's not talked about a lot, but core infrastructure exploits are kind of interesting. The guys at ERNW owned an entire metro carrier Ethernet provider. They were essentially able to, once they got onto the network, subvert and transparently redirect traffic without the knowledge of either party over an MPLS network, and did so because they were able to use old school tools that allowed them to essentially shift labels around by detecting and running a basic cracking application on the shared secret that was used, which happened to be the name of the router vendor. Really embarrassing, right? Then you get things like, okay, what about the free email archival capabilities that we get for free as U.S. citizens by the NSA? We've heard that we have people tapping and intercepting data and voice phone calls. The expectation of privacy because you're going over MPLS networks and they're quote unquote encrypted doesn't mean a whole heck of a lot. And then the notion we heard yesterday that I've been talking about for a while, that virtualization and cloud really forced a return to these big flat layer 2 networks. So we actually see the return and adaptation of old school tools like Yersinia and Ettercap. And you'll be amazed at what at what you can do with these basic old school attacks. We've seen stuff that Joanna Rakowska has done in abusing monoculture levels with hypervisors. Which is scary to say the least. I was really annoyed about how it was originally positioned, and then I kind of cleared my head a little bit, because the implications of Zen in cloud providers is much more profound today than, for example, what it means for Zen in an enterprise, because they just don't have that penetration. So at first, the way it was being talked about, I kind of didn't get the impact here. But when you start to think about what this means in open source environments, what it means in a vendor that has 90% of the market and virtualization layers, both in the enterprise and now expanding to cloud, is quite frightening when you can think about bypassing things at the chipset layer. So the introduction of monocultures is pretty interesting. When we start thinking about shared images, where you can basically go to one of these portals and say, I'll have one of those, and launch it in 10 minutes. The interesting point here is whether you go to VMware, whether you go to Zen, whether you go to VMware or Amazon, you're downloading packages that you quite honestly don't know what's in. Are they already Trojaned? Are they already rootkitted? What do they do? The guys at SensePost at Black Hat last year did a great thing where they talked about putting a really sexy named AMI up on Amazon, and people just downloading it and launching them. Right? Phone home, they could have done anything to those images. And most people who are just taking for granted that they're secure and not applying reasonable common sense things, especially when you think that mass market consumer versions of cloud are targeted at the SMB, they're not going to armor these things. So they're going to deploy more and more insecure operating system application stacks. We see things like that aren't supposed to happen, that are theoretically improbable, not impossible. But Aaron Tromer and the guys did this really interesting thing where they used brute forcing to be able to actually detect where the next iteration of an Amazon AMI would be placed. So they could actually brute force placement of an image next to a corresponding target. Now it got handled and discussed. Like, unfortunately, they talked about side channel attacks as being the kind of concern, meaning, even though the attacks weren't possible, that was the hand waving that the vendors started to use to say this is irrelevant. What they were saying was, no, look, we're white hat researchers. Imagine what black hats will be able to do if they can essentially predict where workloads are being placed. This was interesting too. Guy Rosen, there's a thing in World War II where the Allies were trying to predict how many panzers the Germans had, so they came up with all these statistical models, and then some guy said, I think we should count the serial numbers, and that basically told them how many tanks they had, to the accuracy of like plus or minus 5. It was pretty interesting. So Guy Rosen did something where he was able to use resource IDs to abstract very similar usage. You could actually then, if you were a black hat, imagine probing to see if somebody's using auto-scaling to predict how many things they will actually scale to know how resilient it is, and or force a failover to another region. So you can start thinking about, again, iterative notions of infrastructure that people weren't thinking about. And then this guy over here, I renamed his attack, if you want to call it that. Should I call it that? His research. His research. I call it vMotion Poison Potion. Where ultimately the interesting notion here is if you apply this to, let's say, one of those owned MPLS networks, the thing in the middle here, you have the capability to intercept data. In this environment with this virtualization vendor, when you do something called vMotion, you can actually have a running image over here, and then you can chunk it over this network, and actually at a point in time in which it's ready to operate, you basically deactivate this one and activate this one. And this nasty character over here was able to inject, because that network is unencrypted, was able to inject code and have code that is different running over here than it was over here. Very interesting implications if you start thinking about mobility and what that means. John, I don't know if you pointed out at Intel that time of that talk that there's indeed a checkbox in the GUI that says please encrypt this network. You can check it all you like, but at least at that point it did nothing. It was a future placeholder. Has that been fixed? Okay, so don't check that button, or check it and be pleasantly surprised when it doesn't work. I think I'm actually over time, but so anyway, going up the stack, you've seen cloudburst escapes. Oh, look, 2 of those 3 people are here. We've seen DNS attacks. We've seen BGP attacks. Prefix hijacking, man in the middle. These handshake kind of polite clients wouldn't do this type approaches to security in the internet with core protocols that really enable all of this functionality. issues with trust models of the consumption at the consumption layer that interact with services like BGP, like DNS, like SSL. These things are fundamental today as we move the trust to like the fact that the client itself is reasonably secure, puts us at extreme jeopardy. And then we have developers who would just want to kind of go out of their IDE, their integrated development environment, push deploy, and have it move to the cloud. And that's not unreasonable. To them, cloud's just a platform, right? They don't want to think about infrastructure. But then we have this notion of DevOps that's starting to come. It's really starting to intrigue me, where developers are starting to write policy and code within the applications themselves and use scripting to essentially automate everything, including security. Or at least that's what they think they're doing. I'm very interested in understanding how this notion of developers and operations staff working together in harmonious glee seems to avoid the fact that if we as security professionals can't automate 98% of our security infrastructure, how are they doing it? Okay, it's I think ultimately it's just squeezing the balloon problem, right? They think they're going to fix everything in the application, ignoring the transport, because in public cloud, that's pretty much all you can do. But if we're in a hybrid model and we're not in public cloud environments, I have to secure my enterprise. What is this new model of developer operations going to do to us? And I think that's fascinating. So you can either go to lunch, or I got 8 more minutes. All right. So what's interesting here is we bubble up. This was an interesting thing about failure and owning failures. So there's a company called Bitbucket. They ran a storage repository on Amazon, and they were down for like 20 hours or so. And there was this big complaint and brouhaha back and forth. And it's very interesting because when they wrote up their summary, they said, "Look, we were attacked. It was giant. It was basically a big, massively scaled DDoS." And this was the customer. And what it was, so after 16 or 17 hours, Amazon was able to figure out, in conjunction with the customer, that they were under attack, UDP floods. What was interesting about that was, that it took that long, and people were saying, well, shouldn't Amazon have detected a DDoS? Shouldn't they? Well, I don't know. How do they know what's good or bad traffic? How do they know that wasn't, another Animoto gigantic, successful marketing effort? They don't look at the traffic. And moreover, the customer couldn't see it because once it hits the security groups and basically IP tables in the kernel, it just gets dumped. So they didn't see it was being flooded, so resource starvation, DDoS. So that's kind of the customer's perspective. What was interesting about that is, when I look at this, and I say, if you are silly enough to single source all of your infrastructure, no matter how resilient, to a single provider, you're going to get your ass handed to you on a plate. And what was very interesting was, from Amazon's perspective, they rightfully came back and said, hey, you used a single instance in a single availability zone in a single region. Why didn't you take advantage of the high availability functionality and put another, so who owns this failure, right? Is it a mixture of both? Should Amazon have detected the DDoS? Should the customer be more, aware of the pros and cons of using cloud? Should they have redesigned their application? Should they have taken advantage of the cloud platform? It's a little bit of both, right? And we see this more and more. We've seen, for example, people's concern about Amazon's response to things like this mass-scale SIP attacks, where bots were launching targeted attacks in DDoS floods against SIP-enabled end nodes on the internet. They basically said, well, we don't know if it's good or bad, so we generally we take your report and we try to get the two parties to talk. Well, if that's a botnet, good luck with that, right? You're not going to be able to get them to talk, but they're in a delicate balance of trying to maximize availability and not shut people out. So Benjamin Black said, marketing is not a root cause. So if you believe what you read without understanding the implications on your architecture, that's going to be bad. So cloud does not obviate your need for application security. It doesn't help you with things like information exfiltration, data leakage. For example, with Amazon as a good example, there's no outbound filtering. So unless you have something on the host, right, even those inbound ACLs, non-stateful, there is zero outbound ACLs in those security groups. So if you get owned at an application layer, then I can take that information if I have no protections on the end node itself and just start shipping off data anywhere I like, right? So this notion of how I would then protect and where I invest means I have to put more stuff on the host. I talked about this for the last couple of years. It's become more popular now to talk about mainstream-wise, but the cloud being used as a giant botnet happening, right? That's all I really need to say about it. This notion I coined a tricky little term called EDOS, which is economic denial of sustainability, which is essentially, for lack of a better description, a variation on click fraud, where I essentially use the scalability of cloud to do bad things, drive up the usage of compute, network, and storage, for which you as a customer are ultimately billed. and then you get no money out of the backside of it. So your bill ends up being $100,000 and you sell $10 worth of stuff. I put you out of business, right? Interesting notions here that are starting to be use cases for security in cloud, just a couple of them. But what's interesting is we still have all this crap, right? The OS top 10, still there, still affects a ton of folks in cloud. Mostly because we do a poor job of application security. But what that also means is there's kind of the pros and cons, right? The reality is that in certain cloud services, there's an amount of goodness you can spread in a very quick time. Alex referenced this yesterday, where I can roll out a fix, a change, a new piece of functionality to millions of users very, very quickly. Right, which is good. I can also do that where it becomes very, very bad. Here was a great illustration buried like 7 conversations down in the support forum that said, by the way, in 2 weeks, we're changing the policy in Google. And what that policy was anything that you happen to, if it was private in a group or discussion that you link to externally, that we crawl, is now public. So people would click that little cool thing in Google Voice that said share, their voicemail transcriptions, and you could then do a Google search and start reading and listening to people's voicemails. Because they weren't understanding, just like Facebook, right? You gotta have a freaking PhD to understand what the privacy settings actually mean. But better yet, they can roll these changes and you don't necessarily know what it impacts. So there's good and bad associated with that. And how we understand, depending upon the level of service, what one of these policy changes means to us is pretty critical. Also, this is pretty interesting to me, and I haven't updated the slide, but I use Twitter as an example. There's a lot of Web 2.x apps that were painted when they came out as being cloud that had no cloud essential characteristics whatsoever. They were built on monolithic stacks, running at a colo provider, just like every other app in the world. And this was when Twitter was getting flooded. We came to find out that Barrett actually came to find out that they were basically, externally load balanced to what ends up being a single source provider. Now they've changed things, but interestingly, what we found is that you're not supposed to have this sort of overcapacity issue in cloud. It's another expectation, the illusion of infinite scale. The reality is depends on how you provision your apps and what your cloud provider is like and whether you've architected this way. And in fact, they just announced that they're going to build their own data center. So they're moving away from hosting a co-location provider. They'll leave some stuff on AWS, but to handle capacity and better control and better security, they're building their own data center, which is the antithesis of cloud if you look at how it's marketed. Like, why wouldn't you just put everything in AWS? Well, again, not all clouds are built equal. Now, I'll use another extreme, which is kind of a good example, which is Heroku. Anybody heard of Heroku? They allow you to do Ruby on Rails deployment really easily, right? So their architecture is really slick. Here's all the layers. You got but you've got all of this abstraction, which actually, strangely enough, sits atop even more abstraction. What do I mean by that? I mean that Heroku actually runs on AWS. So here's the layers. You've got Nginx, you've got Varnish as a cache, you've got Erlang as a routing mesh, you have their Dino grids using Debian Linux, and then you've got PostgreSQL, Memcached, and a whole bunch of stuff. So these are multiple tiers, multiple layers of incredibly complex capability to allow somebody to bring up IRB, push to Git, and deploy an app, right? Really easy. All that single button push IDE functionality, all of that is sitting upon all of that. So what's interesting about that is that's a fantastic example of using cloud and application architecture. Could you imagine trying to troubleshoot where something broke in a stack like that? As an AWS person or a customer of Heroku or Heroku themselves, really, really interesting discussions about, again, ownership, troubleshooting, and transparency. So this isn't all about new stuff. This is about being pragmatic and practical about how things ultimately get operated. And what's missing is a lot of the threat modeling and risk assessment and pure common sense management. We get so wrapped up in trying to, say cloud, we don't necessarily understand what's different or what's the same. And if we look at these, most of these problems are exactly the same sets of problems we've been having for a long time. The providers still have them. They focus on maximizing, in many cases, availability, but much of this is out of your control. The reality is, in the last couple minutes here, you're at the mercy of what your cloud provider gives you in terms of security capabilities, or you're going to be implementing, if it's infrastructure as a service, you're going to be implementing a lot more stuff in the host. There's all sorts of interesting technologies that are looking to fix problems in a way that I think are being responded to quicker than they ever have before. In infrastructure, we're seeing some of these converged compute, network, and storage solutions, and even though I implied that they are complex and more difficult, they also give me a single pane for management and policy enforcement. A lot of the virtualization platforms are evolving. Next generation IP networks, which give more visibility and media aware capability to these networks, which is good for some things, bad for things like privacy. So at the infrastructure layer, we're churning, and we're getting answers, and we're having folks look at how they need to manage infrastructure differently. At the metastructure layer, we're seeing things like DNSSEC, extensions to BGP, IPv6, new protocols to separate things like location from resource, like Lisp and HIP, open APIs and interfaces. Infrastructure is still a frickin' nightmare. We still have buffer overflows. We still are struggling with basic capabilities at the application layer. And ultimately, this can be seen as good, but also bad. This layer is completely disconnected from metastructure and infrastructure, and I mean in every way. Not in ways like Alex talked about yesterday with messaging buses where you can actually get good telemetry. It's just, applications are built to ultimately today be completely invisible to infrastructure and vice versa. And what that means is, since we don't do a good job of instrumentation and telemetry, we're unable to essentially correlate what's happening in each layer to figure out whether something bad or even good is happening. So as we wrap up, the reality is here, attacks on and using large-scale cloud providers are happening. They'll continue to. Hybrid security solutions and more of them are needed to give us more tools to be able to better solve some of these problems. Service transparency, assurance, and auditability is really key. I'm working on a project called A6, or more specifically Cloud Audit, which I'll reference later. But it's a way of making cloud providers more transparent across the board, so that essentially the end users, consumers, interested in authorized third parties can make decisions on their security posture. Ultimately, security cloud providers have the chance to make security better, but they can only do that if they're transparent. If they continue to basically deny or hide or provide security by obscurity, that's not going to happen. So we really have helped make this mess. I think the problem is we have to figure out a way to accelerate its pickup. You can join the Cloud Security Alliance to help and also to understand the differences between cloud and normal infrastructure. I really hope you'll do that if you're not already. You can also get involved with Cloud Audit, which I think from a security perspective will benefit us all. I've got the largest cloud providers on the planet right now participating, and we're getting very close to being able to release our first set of namespaces, which allow cloud providers to automate the essentially the dumping of very important information for both audit, compliance, operations, and security into common namespaces that everybody can use to consume using very lightweight protocols, HTTP, as a matter of fact. So you can do things like put the auditors out of the business of collecting data and back into the business of auditing. By automating a lot of that capability. So please do get involved there. At the end of the day, the thing I want to leave you with is that, again, this is about securing your applications and your data, not the cloud. You can't secure the cloud. And I mean that with a capital T, right? The cloud. The providers themselves are the ones that are ultimately going to be responsible. So you're going to have to focus on the things that you can and do have control over, which is your applications and content. And in some cases, a lot of that comes down in the SaaS market to contracts and being able to build a case to management why cost is not the only reason you should. That was not the only thing you should consider when thinking about cloud, because in many cases, if we do a proper risk assessment, we'll find out that the maturity of some of these services are simply not at a level that are commensurate with us putting our most important and critical data out there. So with that, thanks so much for letting me run over. I apologize, and your lunch is waiting out there. If you need to get a hold of me, there I am. Thanks. You can go now.